This will be for the con exercise, verify inverse functions. So just some notes real quick. If f of g of x equals x, or if g of f of x equals x, then f of x and g of x are inverses of each other. So you need to prove one of these two to be true in order to know that f of x and g of x are inverses of each other. And the reason this works is because g of x is the y-coordinate on the function g. If you plug in that y-coordinate, if you plug in that y-coordinate in the f function, you should get x. So in other words, the y, when you evaluate the y value at the function g, you should get x, and vice versa. Okay, so you'll see that in this exercise. Okay, it says functions f and g are invertible functions, and here's both functions, and they want us to write a simplified expression for f of g of x in terms of x. So let's do that first. So f of g of x, that means you want to plug in g of x function in place of x for the f of x function. So we're basically going to take the g of x function here and plug this in place of x for the f of x function. So f of g of x is going to equal f of this right here, 1/4 x plus 3. All right, so we're plugging this in place of x. We have 4 times x, so that's going to be 4 times 1/4 x plus 3. And then minus 3. Okay, distributing 4 times 1/4 is just 1, and we still have the x, so it's 1x or just x. 4 times positive 3 is positive 12, and minus 3. So that is going to be x plus 9. All right, since 12 minus 3 is 9. So that's it. So for f of g of x, we got x plus 9. Just enter that in the box. All right, x plus 9 right in the box. And then the follow-up question, are functions f and g inverses? Well, we said before that f of g of x would have to equal x in order for them to be inverses. We got x plus 9, okay? So that means they are not inverses because we did not get x when we evaluated f of g of x. So that's it. Okay, it says the following tables give all of the input-output pairs for the functions h and j. So here's the h of x function, here's the j of x function. They want us to complete the table for the composite function j of h of x. Okay, so let's see. So for all of these, we have to evaluate h of x first. So we have a blank space here. We see that x is 36, so we have to find h of 36 first. All right, so in other words, this right here, this box right here, is going to be j of h of 36. And this box here is going to be j of h of x, but x is 54, so it's going to be h of 54. All right. So let's look up h of 36 and h of 54. Here's x equals 36. H of 36 is going to be negative 3. So this here is going to be j of negative 3. and h of 54, 54 is right here, and h of x is 16. So this one here is going to be j of 16. So in order to evaluate these two, we need the table with the j function. So j of negative 3, go to x equals negative 3. J of x is going to be 36. And j of 16, go to x equals 16. J of x is 51. So just enter these numbers in the box, 36 right here, and then 51 right here. Okay, so finally they ask, are functions h and j inverses? Well, if j of h of x equals x for all values of x, then j of x and h of x are inverses. So if you look at the table, x and j of h of x match for every value of x. Wait a minute, wait one sec. Okay, right here, it does not match. Okay, so the answer is no. Okay, so if all of these values had matched, then they would be inverses, and the answer would be yes. Okay, see, at the beginning of the problem, they gave us all of the input values for h and j, but one of them didn't match, so the answer is no. If they hadn't given us all of the values and all of these matched, then the answer would be maybe. Okay, but since they said all of them and one of them didn't match, the answer is no. Okay, some more notes real quick. You want to let a and b be constants. If f of g of a equals a and g of f of b equals b, then f of x and g of x are possible inverses. All right. The reason it's only possible is because we're plugging in 2 points, a and b. We're plugging in two numbers, a and b. So those aren't necessarily all of the possible coordinates, all right? But if these are true, it's possible they are inverses. If these are not true, if either one of these are not true, then they are definitely not inverses. So let's take a look at an example. All right, so we have two functions, f of x and h of x. They want us to find f of h of 2 and h of f of 16. All right, so let's do that. Okay, h of 2 means we plug in x equals 2 for the h function. All right, so h of 2, plug in the 2 right there, so it's going to be 2 squared plus 5. And 4 plus 5 is just 9. Okay, so h of 2 is 9. So we're looking to find f of 9. That means we plug in 9 for the f function. So right in there, f of 9 is going to be radical 9 minus 1. Okay, radical 9 is 3 minus 1, and that just, radical 9 is 3 minus 1, and that just equals 2. So you just put a 2 right here in the box. Okay, now we want to find f of 16. You plug in 16 for the f function. So 16 goes right in there. It's going to be radical 16 minus 1. Radical 16 is 4 minus 1 gives us 3. All right, so f of 16 is 3. And now we're going to find h of 3. Plug in 3 for the h function. So that's going to be 3 squared plus 5. And 9 plus 5 gives us 14. So you just put that in the box. Okay, so we have answers of 2 and 14. Based only on the previous compositions, is it possible that f and h are inverses? Well, the answer is no. Okay, it's not possible. Because this right here would have to been 16. Okay, now if this were 16, then the answer would be yes, it's possible. It's not definite because we only plugged in 2 values, okay? We didn't prove it for all values of x. But see here, we already proved it's not even possible because it's not true for this value of x right here. So the answer is definitely no, it's not possible.